So our topic with this one is how to interpret motion graphs. So motion occurs when an object changes position over time when compared to a reference point. So the only way we know if something is moving is if we have a fixed reference point. Or if it's not fixed, at least it's relatively not changing its motion much compared to the one that is. So the only reason we know this car is moving is based on where it is in relation to the tree. Change in motion, we frequently measured as meters, miles, kilometers over a specific unit of time, such as seconds and hours. A useful way to show motion over time is a distance time graph. The y-axis is the distance traveled from the start. So that's how far they go from the beginning. And then the x-axis is going to be the time taken from the start. So the time just going to keep going. So for example, when we look at a distance time graph, we can actually analyze what these lines mean to show the motion of the graph. For example, on a distance time graph, and make note what the x-axis says because it makes a difference. Distance in this case is a flat line. That means there's no distance gain, there's no distance loss. Therefore, we can describe the speed as stopped of the object. If there is a straight diagonal line on a distance time graph, it is letting you know that it is a steady speed or a constant speed. If the line is steeper, like this red one, it's going to be a faster speed. And if it's slower, it's going to be flatter. And if it's going back to the start, it's going to actually go back to the start. It's going to go downward. Another type of graph you might see is a speed time graph. Now, these are different than distance time graphs, and y'all are very familiar with these. So you got to really pay attention what the y-axis says on the graphs because it really makes a difference on how you're going to describe the motion. In this case, the line means speeding up. This means slowly speeding up, and this means steadily slowing down. So these lines are a little different. And when it's speed, that's letting you know, this flat line is letting you know that it is constant speed. It is not changing its speed. It's maintaining that same speed, which is different than up here where it's maintaining its distance. In other words, it's not gaining distance. It's not losing distance. It's staying in the same spot. So those are the main differences between those graphs, and you should be able to describe an object's motion interpreting those graphs differently.